Geometric sequence. It is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called common ratio. It is represented by a letter R. So common ratio is obtained by following this equation. We have a sub 2 over a sub 1 is equal to R, a sub 3 over a sub 2 is equal to R, a sub 4 over a sub 3 is equal to R, and so on and so forth. So let's have an example. Let's try to identify if this given sequence is geometric or not by solving for the value of our common ratio. So let's start with the first one, a sub 2 over a sub 1. So we will have 4 over 2. So 4 is the second term, and then 2 is our first term. So 4 divided by 2 is equal to 2. Next one, a sub 3 over a sub 2. We have 8 divided by 4, which is also equal to 2. For the last one, let's have a sub 4 over a sub 3. We have 16 as our fourth term, and then 8 as our third term. So 16 divided by 8 is equal to 2. So by observation, we can say that all the quotients of our consecutive terms are equal to 2. Therefore, the value of R is 2, and then this given sequence is geometric. So let's try another example. So the given sequence is 3, 9, 24, 27, and 81. So let's identify if there's a value for our common ratio. A sub 2 over a sub 1, we have 9 over 3, which is equal to 3. And then 27 over 9, which is also equal to 3. And then we have 81 over 27, which is also equal to 3. So by observation, we can say that all the terms are equal to 3. And then the value of RR is equal to 3. And this sequence is geometric. So we also have the formula for the nth term of a geometric sequence. It is represented by this formula. We have a sub n is equal to a sub n minus 1 multiplied by r, and a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So when are you going to use this certain formula? We are using the first formula if all the terms in a sequence are given. And then we are using the second formula if certain term is unknown and then limited terms are only given. So let's have an example. So solve for a sub 20 of the geometric sequence 2, 4, 8, and 16. So in this one, we are looking for a sub 20 wherein there are only limited terms given. So we are going to use the second formula. So we have a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So let us know our given. We are looking for a sub 20, and then a sub 1 is equal to 2, n is equal to 20, and then r is equal to 2. So let's substitute all this given. In the formula, we will have a sub 20 is equal to 2 times 2 raised to 20 minus 1. So let's subtract first 1 from our exponent. So it will become 2 raised multiplied by 2 raised to 19. So let's simplify first 2 raised to 19. So we will have 2 times 524,288. After this one, let's multiply 2 by this product. So we will have a sub 20 is equal to 1,048,576. Let's try another. So for a sub 8 of the geometric sequence, 525, 125, and 625. So we are still using the second formula, which is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. Let us know our given. A sub 8 is the unknown. A sub 1 is equal to 5, n is equal to 8, and then r is equal to 5. Let's substitute all these values in our formula. We will have a sub 8 is equal to 5 multiplied by 5 raised to 8 minus 1. So let's subtract 1 from our exponent. We'll have 5 times 5 raised to 7. Let's simplify 5 raised to 7. We'll have 5 times 78,125. And then we'll multiply these two. We will have the value of our 8th term, or our a sub 8, which is equal to 390,625.